Hello guys, welcome to Smart India's YouTube channel. Today we will discuss about LeetCode Weekly Contest 1 or 2 solutions. So moving to the first question. In the first question you are given an integer array of hours representing times in hours and you have to return an integer denoting the number of pairs I and j where I is less than j, and you have to check whether hours of I plus hours of j form a complete day. Here the complete day is defined as the time duration is exactly multiple of 24 hours. So you are given an hours here. For this example, if you look at this example, let's say indices 0, 1, 2, 3, and 4. If you look 0 and 1 index, then you can say 12 plus 12 gives 24 and it is multiple of 24. So it is a complete day. Similarly, you'll get indices 3 and 4. Those are also forming a complete day. So you have to check how many pairs exist in such a way that will be a multiple of 24 hours. If you look at the constraints, you are given n, that is length of string, hours length as less than or equals to 100. If it is less than or equals to 100, that means we can simply use a brute force way, like to generate all the pairs. And by generating all the pairs, we can simply count how many number of pairs exist. Let us try to code the simple solution. So if you look here, we are simply traversing two loops and we're checking whether hours of I and hours of j percentile 24, that is modulus 24, whether it is equals to 0 or not. If it is equals to 0, then we simply incrementing the count, otherwise we are not incrementing. So it passed sample cases and then we look for the other cases. Yeah, it has completely passed all the solutions. Now we'll move to the next problem, which is similar to this problem, but only change in the constraints. So if you look here, the length can be 5 into 10 power 5, first thing. So if you apply here n is this, if you apply the same brute force solution, then the time will be n square. So it will be somewhere around 25 into 10 power 10. So it is not possible to go with the brute force solution for this problem. Now, what can we do here? So, first, we have to optimize the solution. So, how can we optimize the solution? Let's say we are maintaining some, we are having some variable or we are maintaining the count of particular hours. And how can you maintain that particular hours, count of particular hours? So, we can use map or dictionary. So, by using that, for the first example, 12 is happening. How many times 12 has occurred in the entire array? 2 times. Similarly, 30 for 1 time and 24 for 2 times. This is for the first example. For the second example, 72 for 1. Everything has occurred for 1 time. So, yeah, if you look carefully, here 12 has occurred for 2 times. That means the one pair can be 12, 12. That has already occurred for 2 times. other pair is 24 comma 24. That has already occurred two times. Now if you look in the second example, here we can pair 0 comma 1, sorry, 0 comma 1 and also 0 comma 2. Yes, but how can you say we can pair that? Already 72 is multiple of 24. That means its modulus is 0. Here also this modulus is 0. Here this modular is also 0. So let us try to maintain something in terms of modulus, and let us try to figure out how many possible solutions are possible. So if you maintain here map of 0, if you take the count of the modulus everywhere, so for the second example, if your map of 0 becomes 3, so reminders of 72, 48 and 24, everything is 0. So you'll increment your map of 0 and your map of 0 will be 3. But by using this count, how can you say the number of possibilities here are 3? So first thing, you can pair 0 comma 1. Next, you can pair 0 comma 2, 0 and also 1 comma 2. So it is basically from all these three, we can pick any two, right? So something like 3C2. How can we write this 3C2? 3 into 2 by 2, and your entire answer for your solution is 3. So basically when you are having modulus as 0, that means already you are having the modulus as 0. You'll just increment, you'll take the count and you will do n into n minus 1 by 2, and you'll add that answer to your counter variable, and at last you'll be returning that. Before that, how can we move forward by for other cases? Let's say, what are the possible reminders when you do with modulus, when you do modulus with 24? If that is hours of I percentile 24, you'll be getting modulus range will be from 0 to 23. So you are getting 0, 1, 2, 3, 4, 5, so on. You'll be having somewhere you'll be getting 12, and at last you'll be getting 23. Let's say if the count of numbers whose modulus is 1 is 10, and count of numbers whose modulus is 23 is 25. Let's say it is 7. So how many number of pairs we can form by for the numbers having modulus 1 and 23? Because if you simply add the numbers whose modulus is 1 and whose modulus is 23, then whole this entire modulus again will, if you do modulus with 24, it is 0, right? That means it is simply a complement of this. So similarly for 2, your complement will be 22, and for 3, 21. So how can you get it? Simply subtracting by 24. So those count, how do you get entire count? So every number here will have 7 ways, right? Can pair up with all these 7 things. Yes. So if you are having 10 numbers, something like this, 10 numbers, it can simply pair with everything. So all these 10 numbers, there are x1, x2, so on, x10, and here let's say y1, y2, so on, y7. This x1 can pair with any of all these things, right? So it will have 7 things. Similarly 7, everything will have 7, so that means it is simply 7 into 10. So in the same way we can say for other numbers. Yes, 12 will be having 22, and what about 12? 12 itself is 12, right? So it can pair up with its its number itself. It is similar to modulus 0. So all the modulus zeros, we are simply pairing up with that. So what will be the total count for when you get modulus 12? It will be same as the count what you get with 0, because you can pair up with the same numbers itself. If count of, let's say if count of 12, count of numbers whose modulus is 12 is count 1, that is y2, let's say it as y2, then what will be your count? It will be simply y2 into y2 minus 1 by 2. So this is a simple count you will be getting whenever you are having modulus as 12. Yes, so we'll handle the cases separately here. First, 0 case and 12 case you will be getting the count in a different way. And for other numbers, you will take the count of its complements and you will be simply multiplying with it, right? So as we have, as the return type is long here, because here our output can be more than 10 power 9. So we'll declare our result as 0. So first we'll try to populate our map. It will be map of I plus plus we are using for each loop. Next thing, we'll traverse on this map. First we'll check whether it dot first equals to 0 or it dot first equals to 12. If then what you are going to do, you are having result plus equals to, first we'll try to typecast it. And what should be the value here? Id dot second into id dot second minus 1, and we will do entire thing divided by 2, right? Now we have typecasted entire thing, and you have completed the first case, and your second case is simple as that. You are trying to get the count of first and map of 24 minus 80 dot first. Next thing, we are trying to make your complement thing as 0, because already we have visited it. Already we have taken the count of entire pairs possible by its complement and in the present index. So make it as 0. And other thing is simply your result. So as we have done using complete result here, try to type it completely. Now I can try to run the code. Okay, we have not declared the map. Okay, we are having some issues. So output here is 1, expected is 2. Similarly here. So what can we do here? If it is first, it is not hours of I, it is percentile 24, right? As we are doing modulus, as we are already storing here modulus here, it should be percentile 24. Then submit the code. As it is overflow here, we have done small mistake. Let us try to write typecast inside the brackets, because this value can be overflown. So try to typecast here itself, so it will not overflow. So try to typecast the variables in a correct way, so you'll not get these runtime errors, right? So now we'll move to the another approach. Rather than using two for loops, can we solve this using one for loop itself? Can we do that? So what is the other way? So other way is, instead of using formulas and everything, as we already know, we'll try to remove this. First thing is, we'll try to find modulus of current thing. How can you find the modulus of current thing? You can use I dot mod, and what will be the complementary of it, or reminder of remaining thing, what will be that? It will be 24 minus I mod 24. That is not I here, it is mod. Okay, here you are subtracting from 24 and you are trying to get the remaining mod. Yes. Now, what is your next step? As we are getting the remaining mod, you can simply add that into result, right? So you will add that to result, and what will be your result here? It will be simply map of remaining. So if already you have visited or already have the count of your complementary thing, then simply add it every time, and then try to increase the count of your present index, and whenever you find the complementary of a present index, whatever the count it might be, it will be increasing. So instead of using formula here, every time you are trying to increment the result at every iteration. So we'll try to run the code and we'll try to submit this. This is for your another solution. Instead of using two for loop, within one for loop, you can complete this, right? So this is all about the second solution. Let's move to the next question. This question is maximum total damage with spell casting. This is similar to the delete and earn question. So if you have not solved this question, and try to solve this question first, delete and earn, and then come and solve this question. So both are same. This small variation and small variation in the question and small variation in the constraints, and everything else will be same. So first try to solve delete and earn question, and then come to this maximum total damage with spell casting, and this is standard DB question. So here you are given an array of powers where every element will represent the damage spell. So you are given multiple spells and they have damage powers. So basically you have the damage thing, right? If damage is 1, you cannot select 2, and you cannot select 3 also. So if it is 1, you cannot select 2 and 3. And if it is 1, you cannot select 0 and minus 1. But in the constraints, it is clearly given. It starts from 1. It not starts from 0 and minus 1. So this case is probably invalid. Similarly, if it is 3, you cannot select 1, 2, and also you cannot select 4 and 5. So basically, these cases you have to handle. So other things apart from that is, so it can be equals to 1. That means if both are equal, you can select the both the things. There is no problem in that. But you should not select x plus 1. If let's say if power of I is x, if you say x equals to power of I, then you cannot select x plus 1, x plus 2, and x minus 1 and x minus 2. Apart from that, you can select anything. So for this question, you can select 1, 1, and 4. So total thing here is 6, right? So output for this given input is 6. And you have got written as 6. If you have selected 3, then what could be the case? If you have selected 3, you could not have selected 1. No, you could not have selected 4 also. So your output would have been 3 according to the given conditions. So this is one possibility and this is one possibility. So in this both the things, you'll go with second one because it is having the maximum thing, that is 6. If you go to the second example, same thing. If you try to select 1, you can either select you can select all the six, both the sixes, and if you try, you can select seven if you select these two sixes. So that's the reason you will be selecting 1, 6, and 6, and the output is 13. So by looking at the question itself, you can clearly understand there will be many possibilities to include and exclude. And how can we solve this solution very easily, or can we make this solution for this given question to solve it much easier in a much easier way? First, by observing the possibilities clearly, we have to sort the array. If we sort the array from the starting itself, there is no need of checking for. If you sort the array, there is no need of checking for x minus 1 and x minus 2, right? We'll try to check whether the difference between next one is less than or equals to, if it is less than or equals to 2, we'll not include, we'll just skip the indices. If it is greater than 2, we'll try to include that index. So that is a small thing we can do. And yes, if you sort here, it will be 1, 6, and 7. So first observation is, we'll sort the array. We can sort the array, but if there are duplicates, if duplicates exist, so what you can do? If there are duplicates, what you can do? Here we can write it as I here. So if there are duplicates, instead of traversing everything, we can maintain some map, right? So if you maintain some map in this way, so you'll be having all the things. So instead of going to everything, so if you know something like power of I, what is the count of power of I, you can simply multiply with power of I, right? So there is no need of traversing on the duplicates for that many times. So we can avoid that by using map. If we are going to use sorted map, and we can easily do this thing. And one more thing, so as there is 10 power 5 here, already complexity is somewhere near n log n. Instead of, as already we'll try to explore all the things, and we'll try to check whether we can include it or exclude it. And for that reason, to avoid extra cases like extra traversals on the duplicates, this is first. Second, if there is duplicates, what we are going to do? Third thing, instead of traversing on duplicates, what we can do? Store all the unique elements in an array and make sure it is in sorted order. So as it should be in sorted order. What you can do to maintain this in sorted order? First, as already you are having sorted map, which for insertion will be taking login time. For traversing the map will take n. So basically it will be n login. So you can directly use traverse and sorted map and take the keys. Traverse on map and store keys. Traverse on map and store keys. So this is your third thing, breaking this problem into smaller parts. So first step is, you need to sort the array. If you are using sorted map, then sorting is also not required, because already in the unique elements, if you traverse on map on the keys, you'll be getting sorted array. So it is not required if you are using sorted map. If you are using unordered map, then make sure you are sorting the array and storing the duplicates also in the sorted manner. That is first step. And second step, already if there are duplicates, instead of traversing that, we can maintain something. We can maintain map. We can store in the map and power of I, and that will be giving that. And third step is, instead of traversing on the duplicates, we will be doing that. Fourth thing is, if and what you say, power of index, like next index, let us take it as index plus 1. So if while this is true, while power of index, what we can do here is power of index, mm, minus, sorry, we can take next index here because already it is sorted, right? Power of next index minus power of idx. If it is less than or equals to 2, then simply try to increase your next index. We'll try to increment it. So we'll try to ignore the cases which are not required or which are not required to include. So basically we'll be using inclusion and when to include and also when to exclude the things, and you will complete this entire logic for this program. So let us try to code it up. First, we have understood, I hope everyone has understood the logic and intuition behind it. Basically, there will be many possibilities. It is not as simple as sorting the things and removing the things. Some might get the idea, just sort the array, try to remove the adjacent ones and try to get the result, but it won't work, right? Because there might be many possibilities and you should take care of those possibilities. So that's the reason we are trying to figure out all the possibilities and we are trying to check the conditions, and according to the conditions we are proceeding and we are traversing on the array. Let us try to code the logic which we have discussed. First, as we have already discussed, we'll use a map, ordered map. Yes, and travels on the power array, and we can simply insert it and increment the count of every count of every number inside the power map, power array. Now we have populated the array. Our next step, we have already discussed, we want only the unique elements, not entire thing. So let us try to write an array which is unique. Now we'll traverse same thing on the map. If you traverse it on map, how do you traverse it on map? You will try to use pushback. After using pushback, what is your next step? You will try to use it dot first. So it dot first. And now your unique map is an ordered map, right? So it is an ordered map. Now we have completed storing all the things in an order map. Now we'll try to use the recursive memoization to solve this problem. Before that, we'll have the end, right? So we'll try to declare this map also globally so that we can access. It is not necessary to pass these parameters inside the recursive call again. So let's try to declare n here, and here the n will be unique dot size. Your next step. Your next step will be, you'll be passing the index. You'll pass from 0th index and you'll pass the unique array, right? So these are the two things which are required as of now. And what is the other thing? We'll use memoization, right? So we'll try to declare the memorization array. Before that, here you can clearly check your power of I is 10 power 9. In the worst case, all the numbers can be 10 power 9 and its maximum length is also 10 power 5. So 10 power 9 into 10 power 5, it is 10 power 14. So it can cross your limit of integers. So let us try to declare this array, whatever the memoization array we are using, with long. And as it is 105, we are trying to make 105 plus 1. So here there are 4 zeros and last at 1. So now memo, so try to initialize this entire thing. How can you initialize this? Use a simple for loop and try to make memo of I to -1. So this is all about this, and whatever this, you will have some helper function where you'll be passing index and your unique array elements, right? So these are done. Now let us go to the recursive function. So you'll be having index here, and you are having vector of unique, right? Now you have two conditions. Int exclude, if you want to exclude the things, you'll be using helper. Simply using the helper, you'll be directly moving forward and you'll be not checking any condition. If you want to include, you'll be having, I've already said, you can have the duplicate values. So duplicate values, instead of counting it for multiple number of times, we'll be using map here. Map, how can you get those things? Unique of idx in, so we'll multiply with the unique of, that is value of it. So key of it will be unique of idx. Yes, you got the value, but it can, both the unique and map of unique both are integers, right? It can cross the limit. That means if it is 10 power 9 into some 10 power 5, it will cross the limit. That's the reason I am typecasting it to long. I have typecasted it. So this is all about the include. Now comes to the main thing. If it is not satisfying our conditions, then we are going to exclude it. So we are going to skip it basically. So before that, we'll try to write next index equals to idx plus 1 while next index is less than n. And what is your next step? Unique of next idx minus unique of idx is greater than or equal, less than or equals to 2. What is your next? You can simply increment your next index with 1. Done. Till here we have done. We have moved our next index and we are moving forward. And now comes to the inclusion. So how can you say we can include it? We have completed, we have skipped all the indices and now we are at the next index. And now here we have to pass unique. So basically for the inclusion, we are adding here include plus whatever the value, what are the next index possible, which is valid, that we are passing at the index, and that's the thing. And here we can make it as long. Exclude also we can make it as long because its values can be increasing. Now what we can do here is return memo of idx is max of include and exclude, right? So this is all about the main logic. Now we'll go to the base conditions. So as if you have already visited the index is not equals to -1. If you have already visited it, then simply remove index, right? So next, if idx is greater than or equals to n, simply return 0. So this is a base condition and this is the main logic about for this particular question. So we have got the wrong answer here. If you look carefully, you could clearly observe we have declared map n and memoization globally. Yeah. So we have also, again we are redeclaring n here. As already we have declared globally, there is no need of declaring, and rest of the things let us check. Memoization we are initializing with -1, and we are checking whether it is not equals to -1 or not. Then only we are trying to return memo of idx. Yeah, and we are skipping the elements. I think it should be fine. Let us try to run the code. Yeah, it has passed the sample test cases. Now let us test for the remaining test cases. Yeah, it has accepted for all the test cases. Now, now this is a standard problem. Now we have passed all the test cases. So in the last previous bi-weekly and weekly contest also, the third and fourth problem was standard DB. So these three contests are majorly standard dynamic programming problems. Hope you are observing these questions. And for such useful content, please do subscribe Smart Interviews YouTube channel. And if you have liked this video, do share and like. Thank you. This is Karthik and signing off.